Okay. You can see the PPT?
Yes, sir.
Okay. You are able to also see me? I can't see you.
Yes, sir, we can see.
Okay. So uh, we can start in about 2 minutes. Okay, let me start. All right, I think uh, Akshay is there, Anuja is there, Manish is there. Others, I suppose will join. Okay, in due course of time. So let us not wait more because it's already 5:20. Uh, the chapter is very long, and so let us start. Okay, let me share. Okay, I think today's topic is financial management. This is very important for all of us because finance is required almost everywhere, and including the energy saving, finance plays a very important role. Okay, so let us uh, go to the chapter. What I'm going to cover in this particular chapter, as you can see, is the need for investment appraisal and criteria. What is meant by simple payback period? What is the return on investment? Present value, internal rate of return, sensitivity analysis, financing option, and ESCO model. These are the sub-headings or subtopics, and we'll go through one by one. Okay, I would like to start. Uh, yes, Manish. Yes.
Yes, sir. I just wanted to ask, in paper 4,
Huh.
there will be all questions from all first, second, third. So
Ah,
I think the chapter 4 will be contributing more in paper
yes.
4, right?
Yes, yes. You see, right now this is the chapter 7 of book 1. So this is made for paper 1. Okay. The book 4, we will be covering again this particular chapter, but more advanced one later on. This will be repeated after such period of time. I think just to tell you the financial management, the next lecture now will be on 18th September. Okay. So the second part, that book 4, will be taken on 18th September. So we will wait for that. But I think this is a good revision for you, Manish. Okay. So let me go ahead. I would like to start reading the first para because first para of this book lesson is very, very important. I'll read not fully, but some of the sentences. Okay. Energy projects are very important to the economy and environment. In case of energy conservation projects, the more the number, the better it is for environment. It's important to justify any capital investment project by carrying out a financial appraisal of the project. However, the biggest constraint in increasing the number of energy projects in the country is the lack of finance. And alternate finance arrangement can overcome the issue of lack of finance. If someone feels there is a lack of finance, I don't believe it. Okay, so that we need to see for that. And however, it so happens that most of the energy managers and auditors use simple payback period analysis only to evaluate the project, but which does not reveal the real benefits. Okay, and there are some limitations also. So sometimes energy managers they avoid taking the energy management because of the several financial terminologies which they have not understood, or they feel that they are going to be problematic to them, they can't understand. So the financial issues become really speaking very important of that energy moderators, managers and auditors must know. Okay. So let us come to the subject. First of all, so this is why I said this is because I'm going to explain some of the terms which or some of the things which are actually mentioned, but they are not clarified in the first paragraph. Okay, let me start the project first with the observation that the title of the project, according to me, is not correct. It is financial management topic in the title. But what we are really speaking, we are going to learn is not the financial management. We are going to talk only about financial analysis and financial techniques and the financial options, okay, or financial requirement. So we are not going to talk about the financial management per se. Okay, this is one thing. Second thing is that we are not going to this is not meant to teach the finance, not the finance subject, but it is to highlight the importance of finance for energy conservation project. So I want to remove some of the myths and some of the things which energy managers and auditors carry. I want to remove some of the concepts which are misconceptions or myths as they call it. In finance management, there are certain terms which we are energy managers, auditors, engineers are not familiar with. Okay, some of the terms are really complex also. Some of the terms are sometimes confusing also. So objective of today's lecture is to clear some of these things, to make things very simple, to make this and clarify certain aspects of it so that you find it easy, you feel comfortable with it, you comfortable with dealing with the financial issue. So that's what we are going to see. Okay, that's what we are going to discuss today. Okay, now let me go to the first part. The first word that is used is energy project. Okay, the energy projects, I think those who are working in the field, they already know energy projects. But there are energy projects that called as energy conservation projects. They used to be called initially energy efficiency projects, or they are or the simple energy saving projects. They all mean the same thing. There's one of the same thing. These are the projects which are meant for which, if implemented and when implemented, result into energy saving. Okay, so this is the definition of energy saving projects or the project. Of course, you will learn more about energy saving projects or energy efficiency projects in next chapter. There is going to be taught under the heading project management. Okay. But there you will know more about the project. But since we are going to talk about energy, I mean, the first two words are related to energy project, I thought let me tell you that they are meaning energy project. And what is energy project? Energy projects or energy efficient projects are the compilation of various energy saving ideas along with the financial analysis, along with the cost benefit analysis, along with the savings achieved and cost benefit analysis of various measures. Now, energy efficiency project consists of several such project saving ideas or project saving measures. They are also called energy saving measures or project energy saving ideas. Okay, so energy projects consist of a bunch of or a number of energy saving measures or projects which face cost benefit analysis and think of the implement those which are financially viable, technically viable. So feasibility, technical feasibility and financial feasibility is studied for various ideas, various energy conservation measures, and they come together and that forms the energy efficiency project. Now, energy efficiency projects are implemented. So all energy measures are implemented as energy saving projects all throughout the world, in the corporate sector, in the organizations, in the countries, everywhere in the world. Okay. So energy, that's why energy saving projects, energy efficiency projects become very, very important to us. Okay, so this and why? What do they do? Why do they require any energy saving project? Basically, it is aimed at saving energy, and so therefore, save it is also meant for the energy security of the organization or energy security of the country, because you are saving energy, through the implementation of energy saving project. Okay, and once you save energy, obviously it is also going to mean that you're contributing to little improvement in the environment. Okay, and of course, if you reduce the energy consumption, and especially in the countries like India, where we are importing almost 85% of the oil, we are importing nearly 53% of the gas today. We are natural gas we are importing, so it becomes economically also advantageous to us if we reduce the energy savings and thereby reduce the energy import content of the oil and gas, and so therefore it helps with the economy. So therefore, the first steps it becomes very important for the country that energy saving projects are important for the energy security, environmental improvement, and economy of the country. Okay, so I hope this you understand it now better. Okay. And as the second sentence is, in case of energy conservation project, the more the number, the better. Because if you have large number of energy saving projects, obviously you are going to implement many ideas, and you're going to save, a lot of energy. So therefore, the more the energy saving projects, and it's of course certainly better for both energy saving, security, as well as the environment. So second sentence also becomes very important. Okay. And so this is the second thing. Third thing is that any energy saving project, of course, most of the ideas which are implemented, most of them require some sort of finance. Okay. Either for various purposes. Why do you need finance? Because you may have to install a new energy saving equipment. You may have to change the existing equipment from energy inefficient equipment to energy efficient equipment. You may have to change some piping. You may have to plug some leakages, etc. Okay, or you may have to do some retrofit. It requires, of course, money. So not only equipment is used, but installation is to be done. Sometimes if the new installation is done, you also mean foundations or civil structure. So therefore, finance is required, and it is in energy saving projects without financing is not possible at all. Okay, and a substantial amount of finance is required. So naturally, the question always will be from where to get the finance. Okay, on how much is the finance required, from where to get it, whether it is whether it is beneficial, and some such questions will always be rising, and they have to be answered by the energy auditors manager, because this is the prime responsibility of energy manager and auditor and energy professional, energy engineer, to implement energy saving projects in an organization. Naturally, he has to understand, not only, of course, he understand the energy saving projects technically, but financial also he has to understand, and he has to convince the management why it is, how it is beneficial, why it is required to be undertaken by the management. And if there are many other projects where finance is required, how energy saving projects become more essential. That it needs to be convinced. And it is here that the experience is that many energy managers or energy engineers, they are unable to first understand what is the project's finance requirement and how convince management how beneficial it is. Okay, so there, this is the experience almost everywhere. And then what happens if the energy manager or engineer or doesn't understand? He tries to ignore some of them. So some of the projects he may drop because if he is not able to convince the financial viability. And then of course the purpose is lost. Okay. So in fact, some of the energy manager feel that, the finance is an obstacle in their understanding of energy saving project, or convincing the management. So that must be overcome. Energy managers and auditors must have adequate knowledge of finance requirements of energy saving projects. Okay. So, and so therefore, this chapter has been introduced because it is essential that energy managers and auditors must understand all the aspects of, related to financial management or financial aspects of the energy saving project. I hope you understood me. the need for understanding of the advantages of financial aspects. Now, let me come to another aspect. In finance, when we talk of finance, there are many terms which finance people use. We hear many times. We understand some of them. We don't understand many of them. So it is necessary that we must clarify. We must have a clear understanding of various financial terms. Okay. So, and sometimes, there is some confusion, there is sometimes dilemma. So we must remove them. So what I wish to, first take up is that some concepts I want to make it very clear so that you have got a better understanding. I'll try to explain in simple language which an energy auditor manager can understand. So not in the financial jargon, because that will help you a lot. Okay, so that will help you to take up the energy conservation projects and also convince the management about it. Okay, okay. So in any case, one thing very certain, unless the management is convinced about the profitability, they are not going to go ahead. So very essential that we must understand the financial aspect very clearly. Okay. So the first thing is that let us try to understand the difference between investment, financial investment, and the expenditure. Okay. These are the first terms that one hears or one talks about it. Now, investment is investment in any project or any as investment is the money that is uh, spent for creating an asset. Okay, whether it is an equipment, whether it is the system, whether it is the installation, whether it is a subsystem which requires investment. So that investment is for creating an asset, and that asset is going to be there. Okay, so it's if I mean. Asset is something which is if it can be sold, it can be and money can be realized. Oh, so money is not lost, money is not consumed. Okay, where the expenditure is something where the money is spent, but it cannot be recovered. Once it is spent, it is gone. For example, energy, expenses. Once you spend for the energy, it is gone. You can't recover it. What energy saving equipment, if you install, yes, you can recover it. And if at all it is to be sold, okay. Nobody is hence that's a different issue. So expenses are something which cannot be recovered. Okay, so this is one difference. Second difference is the cash understanding the cash flow. Now, because when there is money required, there has to money coming in, when money is to be spent, so it is we have to give cash. Cash means in form of check or what, it's not the currency. So what is cash flow? The definition of cash flow is, the money that is spent. Now, when money is spent as an investment, so when you buy equipment, it is an investment. So that is the cash outflow. When that energy saving device or equipment to be operated, it requires energy. So expense for that is a cash outflow. There will be some manpower required which will operate those equipment. So you have to spend money for their wages, salary. It is cash outflow. Okay. Then there will be there will be some incidental expenses, because if you have invested money and you have got finance from some outside, you may have to pay interest on that. So that is also cash outflow. So cash outflow is money that goes out. Cash inflow is actually the after you install an energy saving equipment, you save energy. So the saved energy, you actually speaking, you don't get money. Okay. Saved energy is that you are reducing the energy consumption. So you are paying less for the energy. Okay. That means your energy expenses have got reduced, energy budget has got reduced, and that we call as the saving. So financial savings are also the expense, the less amount that you spend for energy for the energy, etc. So energy saving is a positive cash flow. Okay. So that is our inflow. Okay, that is the inflow. Actually, there is no inflow because no money comes to us. It is the reduction in expenditure. Okay, and that is of course another other than it's a positive cash flow, whereas the expenses for assets etc. is the negative cash flow. So this is another thing that we have to understand. The third thing that we have to understand is the difference between interest and discount. Okay, these terms are used in finance often. Interest, of course, I think all of us know because we all are aware that when we keep our money in the bank, okay, either in the savings bank or fixed deposit, we get an interest on that and we get that money. Okay, so in concept of interest is clear, even a child understands it. Okay, but what is discount factor? Okay, so discount factor is very similar to saving interest. You know, the interest is always mentioned in percentage. So it is 5% interest, 7% interest, 6% interest. Similarly, if you are going to save energy, if to the extent of 5%, they say that if the discount factor. So the discount is 5%, 10%. It's exactly similar to interest, but it is not the money. Money is not involved in it. It is not called as the interest, but it is called as a discount. So this is the third term difference, differentiation is the third term. Fourth is, of course, I'm not talking much about the compound interest because that element doesn't come into the picture at all. Then fourth is the risk of investment. So if any money is invested, naturally, there is some amount of risk involved. How? Equipment that you install may not deliver as per your specification. That means if you are, you are projected to save X amount of energy, it doesn't deliver, it is less than X. So that can happen. Second thing is that you have installed certain equipment which you feel will last for 10 years. It doesn't last. It lasts only 8 years or 5 years. So that is another risk that you have. Or for example, you can install some equipment based on certain loading, percentage loading. Now, if the loading is not that much loading is not put on the machine, it might not so it might reduce less amount of save less amount of energy. So these are the risks involved because there are several factors on the basis of which the energy saving is dependent on. So now therefore, sometimes if the investments are large, they resort to something like they like to resort to identifying the risk and some risk mitigation or efforts or means are also adopted. Okay, sometimes the insurance, of course, you understand any insurance equipment that is insured installed this insurance because if something goes wrong, then you have to recover that money. So this is the fourth term, fifth term. There is another one term which is often used is word depreciation. Okay. So if you invest in something, you create an asset, the asset value, because of the use of that asset over the period of years, the asset value reduces and income tax department allows you to reduce its cost by a certain percentage that is defined in income tax rules. So if 10% depreciation is there in the first year, they allow 10% of that money value or that equipment. You can reduce that from the profit. That means you can reduce that from the expenditure. Okay. So that is the benefit. That is the meaning of depreciation. So when you install an energy saving equipment, you are getting a financial benefit in your income tax by giving that much of 10% of that value and deduct it from your taxable income. Okay. Now, in case of certain projects, some financing element, the depreciation normally usually that benefit goes to the user or the owner company. Sometimes it may go to the person who has installed it. That means he is the contractor. So depreciation is also another important point. So these are all certain financial terms which which are used, in they are also applicable to the energy saving project. So I thought let me clear some of these things so that you find the understanding of energy finance for energy conservation project, simple or easy. Okay. So this is what I just wanted to explain. So I hope some of the terms and words used are clear to you, and you unnecessarily don't get panicky. You means unless the auditors and manager don't get panicky, because these are very simple actually. Once you understand, there is nothing much about it. All right. So this so therefore I explained it to you. Now let me come back to investment and finance. Okay. Now the one question that you'll ask is it that energy the finance for energy requirement only engineers or managers have to understand, or energy saving concept only they have to understand. But let me very clearly tell you that the finance people understand the importance of energy saving more than the importance felt by energy auditors managers. Because it is the finance managers and people who know that by saving energy, they are going to reduce their expenditure and it's going to be their profit. So the finance managers are the ones who really understand the need for it, understand the importance for it. And so therefore, many a times they will help you also to provide finance to implement it. So this is many times this part is not understood because most of the manager feels that the finance people are going to only question me how much you're spending, how much benefit you are getting, it is not profitable, savings are not very consistent, so on and so forth. So they feel they are a hurdle. They ask some unnecessary question and make life for the energy manager uncomfortable, but it is not so. Okay, finance people will do it. Let me tell you my experience, in early days of energy conservation when it was just practiced. One of the companies of Kirloskar Brothers, Kirloskar company. I was also with Kirloskar company. So in around, I think around 1980s, the vice president of one company, vice president finance, he said that I am told that you advise on energy saving. So can you do it for us? I said, yes, we can do it for you. We will study and we will tell you how you can do it. So he said that how much saving you there. As I said, it is not possible to tell you offhand, but usually they result into 5 to 10% saving. Now he said that my energy bill is 2 crore rupees. So if I save 5% or 10%, it was up to 20 lakh. So I'm okay with it. You go ahead with the study. Okay. So that is how that was my one of first experience and good experience of the finance people understanding the need for finance. So finance people do understand this thing very, very clearly. So this is just an initial background and what is contained in the first paragraph. And so now let us uh, hereafter let's go ahead further. Okay. Now one thing mentioned here is most energy managers use the payback period. They are unaware of any other characteristics. Now, let's try to understand this word more. Yes, energy managers only know about simple payback period. They don't know what other techniques which are used by the finance people. Some of them may be knowing it also, but not many. So let us see what are those. Okay. So as we go along, we will see about that. Now let's come to this. That why do we need finance? I think I did explain to you that finance is required for installation of the energy saving devices or replacing the inefficient devices or retrofitting to save energy and so on and so forth. Okay. And naturally, the energy manager has to go to finance manager and say that this is our engineering project. These are the various ideas. I need so much of money. So much of money for implementing the project. So the first question that we will ask is, okay, what is the total project cost? Okay. So finance energy manager has to be in a position to work out the investment or the total financial cost. Okay. The second question we'll ask is how much money it will save. So he has to also calculate how much money is saved. Okay, by implementing the measures, and he says how much period will I get that money back. So he has to be ready with the answer that okay, 3 years, 2 years, 2 years, 5 years, whatever it is, and then he puts up the proposal is agreed, and he takes up for implementation. Okay, so this is what should go. So this analysis of, I mean, the need for investment has to be first understood. So, and that investment would mean not only the cost of the equipment, but cost of the foundation, if required, cost of the, for the power supply, which is to be provided, compressed air, which is to be provided, utilities to be provided. The cost of all utilities and facilities required for also operating that energy saving major project, that all costs must be undertaken, labor cost, energy cost, depreciation, everything is to be taken when you work out the total cost of the equipment. Okay, cost of the energy efficiency project. This is the energy auditor manager must understand how much is the total investment required, how much period will be required to receive that money through the saving, and what is the so how many years will be required, and what is the level of saving, so that it becomes attractive to them, because management of several activities for which finance is required, he has to decide which one to take up on priority. So energy managers should be able to convince that energy saving projects is the one they should take up, first. It is not only the energy saving, but there are many other benefits that energy security, environmental aspects they are doing. They can also claim that our unit is more energy efficient, compared to others, and so on and so forth. So there are many other aspects which he has to convince apart from the financial viability. Of course, technical viability, I mean, it goes without saying that he also convinces of the technical viability. So the finance requirement, what uh, we understand. So I think that is what most people would like can do it. Okay. Now there are certain financial techniques which we have to learn, or financial tools which are employed to assess the financial viability, feasibility. Now, there are four methods usually employed for assessing the feasibility, economic feasibility of equipment. So first is the simple payback period, which is really simple. Second is the return on investment, ROI. It is also very simple. But two other techniques which are used for some, where requirements of finance are large, there some complicated things are involved. So one is the net present value. It's the third, tool that is used, and fourth is the internal rate of return, IRR. Okay, these are the four techniques which are used, which energy auditors and managers must understand very clearly. And these are very simple. Actually speaking, they are very simple. Okay, when I explain to you, you'll all find that they are not at all difficult. Well, and it's more or less, this is the psychology. In fact, a finance subject itself is very simple. Once you understand, there's nothing, it's a more of a common than, technical learning, which is required for energy saving. Technical part, financial part is same everywhere. We will take a project or energy saving project or any other. So let's talk about what are the tools and for used for analyzing or the energy saving project. The first one is payback period. I think most of us know about payback period. I will not spend much time on that. You all know that it is the amount, it is the time in years to receive the investment, back in form of the saving. Okay, so it could 2 years, 3 years. So you invest money, and after within 2 years or 3 years, you get the money back. Okay. So the simple payback period, the definition is the capital cost or annual net saving. I would rather put it here that it is the investment, investment including any the cost of the equipment, installation, everything in totality, and the annual saving. Okay, so annual saving means as you, whatever energy you save, whether electricity or fuels or this thing, the tariffs and rates are known. You calculate the amount of saving annually. So all this exercise is done on an annual basis. Okay. So investment done, you have an annual saving that gives you the number of years to get the money back. Okay, so number of years. So it is called the payback period. Now there is a word you can see is the simple payback period. What does it mean? First, very simple answer is simple payback period is just tells you that it's a simple way of analyzing an investment, and after investment required annual savings, which can measure will give the or we can estimate will give the payback period. But there is another meaning to it that simple payback. It tells you that the time value of money is not taken into account here. Okay, so we just invest, say the first year, second year, third year, fourth year, fifth year that you add. Okay, that you are adding, but no time value is taken. What is time value of money? We will go to that little later. Okay, I'll explain to you. So the word simple means it is a simple method calculating the payback, period. Okay. Now, example given over here, I will just very quickly go through. There is a cogeneration system installed with a, where the that cost is 90 lakhs of rupees, cost of that. It is aimed at saving 23 lakhs of rupees annually. Okay. And for operating and maintaining that cogeneration system, you have to spend 5 lakhs rupees annually. So what it means that 90 lakhs rupees the investment that goes into the denominator when you want to calculate the period now. Sorry, that is nominator. So nominator is 90 lakhs, whereas denominator is the same 23 lakhs minus expenditure, operating cost 5 lakhs, that is 23 minus 5 is equal to 18. So the payback period is 5 years. Very simple calculation. Okay. Now, advantages of this calculation of simple payback period is both simple in concept and also the application. And usually one knows that shorter the payback period, the better it is, because that you are going to receive your money back at, as a, at an early period. Okay. And it also favors the project where the savings are more in early years. Okay. So what does that mean? We will understand this more by taking up this example. Okay. So let us try to calculate, do this calculation of a period where you will come to know what is the drawback. Okay. What are the limitations of a period? It may not drawback, but I will call it limitation. So this example, you can see that there are two projects A and B. In case of project A and B, both the investment is same rupees 1 lakh rupees. In the first year, in case of project B, you get save of 50,000 rupees. In second year, 30,000. Third year, 20,000. Fourth year, 50 or 10,000. In case of project B, with the same investment, you are saving 20,000 rupees for the first year. 40,000 in the fourth year, and 50,000 in the first, 50,000 fifth year, 60,000 in the sixth year. Okay. Now, if you just add on, for 3 years, you can say for project 1, 50 plus 30 plus 20, 1 lakh rupees, you are getting it in 3 years. Okay. So it means that payback period is 3 years. Whereas for project B, 20, that means you are only going to 60,000 rupees in 3 years. So, and if you add the fourth year saving, it is again 1 lakh rupees. So that means the project payback period is 4 years. Obviously, anyone would say that A is better, because payback period is 3 years. But it is not so. It is not so because if you add, let's say add for the 5 years, you'll see that for project A, it is 50 plus 30 plus 20. You are going to get 1,20,000 rupees. Whereas for the project B, you are going to get 1,50,000 rupees. So obviously, in 5 years, if 5 years the life of the equipment, you are getting 1,50,000, whereas the first project gives you 120,000. What it means that you don't, if you don't calculate the payback period till the end of life of the particular energy saving device project, you are likely to be misled and you are likely to come to wrong conclusion. Okay, so you have to do payback period calculation for all the years that it is intended to work. Okay, so this is one. This is one. Second thing is that again here you are not taking into account the when you are saving 20, 20, 20, etc. in years, what it means today. Okay, so what is the real saving as of today? Okay, I don't. We all know that value of money it reduces over the period of time. Okay, so these are the this is the drawback of this particular term. Okay, so let us go to now second method of calculation or financial analysis is the return on investment. What is return of investment? It is expressed as annual return, annual net cash flow. That means the savings over the investment, that's the capital cost. So how much you invest and how much net saving you are getting annually, that decides the return of investment. For example, again we will go to this example given over here. So it says that there is an outlay of 1 lakh rupees. That means the cost of the equipment or the investment is 1 lakh rupees, and it's expected saving of rupees 125,000 per year over the next 6 years. Okay. So your saving is 25,000. That is the numerator, denominator, the investment that is 1 lakh rupees. So it's very simple. You can calculate it 25% is the return on investment. So, okay, you feel good. Return of investment is 25% good because normally we compare with interest that you are going to get. Okay. When we invest money in the bank, you get 10%, 8%, 11%, whatever it is. If you invest in energy saving device and the return of investment is 25%, you are happy because you are going to get much more than what you have if you have kept that money in the bank. So that is, it gives a quick idea about the the attractiveness of the investment. So it is also another simple method, easy to calculate, and the returns are expected at percentage which we are all used to it. No, 25% saving. Okay. Again here, if the saving was not 25,000 rupees every year, it was varying, then that calculation it doesn't hold good. You'll have to do it for every year. That's another problem. Second thing is it also doesn't take into account the value of money. Okay, that is another limitation. So these first two methods are simple, but they have some limitation. Okay, limitation. So we have to then in that case we have to resort to the next two methods, that is the net present value and internal rate of return. Okay. Now first let us try to understand what is time value of money. Okay. Uh, by the way, have you understood payback period and ROI, return on investment? Is it clear to you?
Yes, sir.
Okay. So I will proceed further. A project usually, time value of money. You have all of us know that if you have got, let us say, 100 rupees. Okay. For simplicity, this example is given over here. I will only repeat that example not to confuse you more. So if you have 100 rupees and you deposit it and interest rate is 10%, you are going to get 100 plus interest 10% after 1 year. That means you are going to get a total amount that you get back is if you get deposit back is rupees 100 plus 100 plus 10% interest, that is 110 rupees. Everyone knows about this. Okay. So that means the value of money, if it is 100 rupees, after 1 year, it is 110. Do you understand? If you have 100 rupees, after 1 year, that value will be 110 because you would have earned 10% on it. Is this clear? Concept clear? Is this concept clear?
Yes, sir.
Okay. So this is a very simple concept. This is called the future value of money. Okay. 100 rupees is the present value of money. 110 is the future value of money. Okay. So the financial people will use the word present value, net present value, future value. It is very simple. What is the value today? 100 rupees. Next, after 1 year, it is 110 rupees. In the second year, at the end of second year, it will be 10% per 10% interest of 120 rupees, and so on. Okay. So even if you assume, don't assume compound interest, it will be 100 rupees plus 10 plus 20 plus 30 plus 40 rupees will get added to each. So that is the future value. Very easily can be calculated, right? So in terms of now working backward, because we are all making investment today. Okay. So whenever a profitability is to be worked out, as of the date of, assuming today it is to be invested, if I invest some amount today, that after a certain period of time, I'm going to get my money back. So if next year our cash flow is going to be 100 rupees, what is it today? So 100 rupees, it is saving tomorrow. What is it today? Now, by the same logic of future value, 100 rupees after 1 year becomes today it is 90 rupees on 90.91 to be precise. You add interest to it, 10% interest, it becomes 100 rupees. So 100 rupees that you receive in the first year is 90 rupees, is the value today. Okay, so that is the value of present value. So the expression that is used, mathematical series, Fourier series is used is future value of money is equal to net present value. That means that today's value into 1 plus I to the power n, where I is the rate of interest. If you get 10%, 8%, 6%, whatever it is, what is the prevailing rate that you consider to the power n is the number of years that you expect that investment or that in energy saving project to last. Okay, so you can calculate how much is the what is the value as of today, what is the value of future, or you have to calculate as of today what is the cost, the future value, that means future cash flows. You can convert it to today's cost, today's value, and by a formula HV by 1 plus I to the power n. Same inverse of that. Okay, very simple. Okay, so you can calculate future of money today, or today what is the money that you are going to receive tomorrow. So investment is the investment put by today. Cash flows, that means the savings are there, they are going to be the future cash flow. So you need to convert them into today's value. So net present value is, this method is it. So therefore, it is in your express in a series, net present value is equal to minus CF0 by 1 plus k to the power 0, CF0 by 1 plus k to the power n. Because it is the same expression, but written down here for 1, 2, 3, 4, 5, 6, 7, n years. Now, the investment, as we mentioned earlier, is then negative cash flow. So it is written negative. If 1 lakh is invested, it is minus 1 lakh. If you get 10,000 rupees in the first year, CF1 is the 10,000 rupees by 1 plus k. Now, interest rate, if you are going to pay is 10%, you write over here. So 1 plus k to the power 1, of course, 1 to the k to the power is k itself. So you go that way you go on calculating for various years. Now, so net present value is NPV. CF1 is cash flow operating that 0 is first year, second year, third year, fourth year. N is the life of the project, and K is the discount rate. It's not called interest, but it's called discount rate. Okay, so it is here that we first time use the word discount rate. Now let us take up a example to understand it more. Okay, so how do you calculate net present value when your cash flows in next, say, few years? They are known or they are estimated. Then how to calculate the net value as of today? Now again here we are considering two projects, project 1 and project 2. For both the capital investment or the capital cost of investment is 30,000 rupees. In case of project 1, as you can see in this table, net annual savings are 6,000 rupees, which is constant for 10 years. In 10 years, your saving 60,000 rupees. 30,000 is the cost of the project. In case of project 2, the savings are varying. In fact, they are more in first 2 years, 6,600, then reduce 6,300 in the year, third, fourth year, 6,000 in fifth, sixth year, 5,700 in seventh and eighth year, and 5,400 in ninth and 10th year. Again, if you add them, total savings is 50,000. So you will apparently say that both projects are same. That means you got an investment of 50,000. After 10 years, you are recovering 60,000 in both cases. So both are same. Now, how do you choose? Because the question will be whether you choose project 1 or project 2. Okay, so that if that choice is there, you calculate net present value. Okay, so what is net present value? Now this calculation is very simply given out here. I'll read the first two terms of this. Investment 30,000 is minus 30,000 by 1 plus in k to the power 0. Now, anything k to the power 0, interest rate here we are assuming that we should get 8% return minimum and calculate what is the net present value. So interest rate or the discount factor is taken as 0.08, 1 to plus 0.08 to the power 0, everything to the power is 1. So this quantity is 30 minus 30,000. The second term is 6,000 is the investment. This is for project 1. At the end of first year, 1 plus k to the power 1 is equal to 1.1 plus 0.08. So 1 over 0. Now this works out to 926. Second year, 1 plus 0.08 to square is the denominator, 6,000 is the numerator, 6,000 into 0.857. This quantity, 1 over this is quantity 0.4%. So you work out, you calculate all these things and add together, you get a value of 10,254. That is the net present value, okay, of this particular project 1. Similar exercise is done for the project 2, where you are taking the cash flow or the 600, and so on for different years, and you calculate in similar fashion. The final answer that you get is 10,867. Okay. So the net present value of project 1 is 10,254. Net present value of second project is 1057. So someone from you tell me which you buy by your gut. What is your gut feeling? Which is better? Net present value more is better or other one? You have to answer. Yeah, someone go ahead, please answer. Common logic will tell you. Are you listening to me? Are you there?
Yes, sir.
Then answer. Yes, answer. Which you think will be the correct, the better project? Anuja?
Sir, actually, your voice is little breaking, so I did not understand the question.
Okay, my question is, if the net present value for the first project is 10,254, for the
Yeah,
second project is 1067,
yeah.
8,867. So which the net present value for project 2 is more? So which is better?
Second is better.
Second, the common sense
Yeah,
tells you that second
yeah,
is
yeah.
better, but financially also, since you have present value that the money that you are going to realize in 10 years, if it is converted into today's value, it is 1087. So you are safer. You are getting more. You are going to get more. All right.
Yeah,
Return.
sure.
So this is better. So all the 10 year span, project 2 is better. So you will select that particular project. So it takes into account the value of time, money in time. Okay. So you are taken into account first year, second year, third year, what is the present, converted into value today, and worked out. So it takes into account value of time. You understood?
Yes, sir.
Okay. Now let's go to the fourth character, fourth tool, financial tool, or fourth method of working out. Okay. So it is the internal rate of return. Now again, what is internal rate of return? Is the return that you are going to get, after, if you make certain investment. Now how it is calculated? The simple formula that is used is you equate the net present value to zero. Okay, what it means is that you work out the whole thing for this exercise you will complete, put it is equal to zero and try to find out the discount factor K. That means how much return you are going to get, 8%, 10%, 5%. You know the investment, you know what is the capital in first, second, third, fourth, fifth year, and you want to know what is the return. This is the internal rate of return, how much it is. So here this value is equated to zero and you work out. Okay, and you calculate what is K. Now, how it is done, I think we will go to the example, then you will understand it little better instead of talking in air. Okay, so here there is an example where 20,000 rupees is the investment, okay, and the cash flow is 6,000 in the first year, that means saving. Second year, 5,500 savings. Third year, 5,000. Fourth year, 4,500. Fifth year, 4,000. And sixth year, 4,000. This is the saving that you're going to achieve in first, second, third, fourth, fifth, sixth year, right? 20,000 is the investment. So this first, quantity becomes minus 20,000 because that's the investment minus 20,000. Second is 1 over 1 plus k to the power to the power n is for the first year. 6,000 is the saving. Now, what is the k? You assume, you make assumption that, okay, you feel that you might get 8% return, in this exercise. You put the value as 0.08, okay, and you calculate second year, 5,500 divided by 0.08, 1 plus this square, etc., etc. And you work out, the whole exercise is done. It is equated to zero. So this is equal to zero. So you find that the whole thing was, it is first is the NPV. You calculate. So this is NP is equal to 2,791. That is what you have calculated by assuming K, as 0.008. Okay. Now you want to come to a figure, this figure you want to bring it to zero. Okay, which means that you are not near the 8%. You are actually return are going to be less or more. So you have to make an iteration. You have to make the type. Now it is for the sake of calculation. They have increased the discount rate to 12%. Instead of 8%, it is 12%. And you work out the whole thing, you find that the answer is 495. What does it mean? By 8%, you are getting NPV is equal to 2091. By 12%, you are going to 492. So obviously, it means that actual rate of returns, internal rate of interest is more than 12%. Okay. That is by hunch, you know it. Okay. Now, you take a value of 16%. Okay. Take a trial with that, and the value becomes minus 1,501. What does it mean? So it is somewhere between 12% and 6%. Okay, this is one conclusion that you can, or observation you can have. Second observation is with 12% as the discount rate, the figure is 495. With 16% return is a minus 1,500, which means that actual discount rate is somewhere above 12%, but nearer to 12%. Okay. So here they have a rate of 13%. Okay. That is assumed. And you calculated the value is minus 65. That means it's very close, almost an answer, but it's not zero. So if you really equate this to zero and calculate this K, Now it will work out that the value of K is 12.88%. That means the internal rate of return is equal to 12.88%. Now this is the what we have calculation done here. NPV is at 13% in K discount factor. NPV is minus 65. NPV at 12% discount factor works out to plus 495. You can do this, by interpolation. You can work out I have to 12.88. Okay. Another simple thing is if you can plot it on a scale, 8% discount, 12%, 16%, and you put the NPV on the vertical axis. So you will find that the intersection point is somewhere between 13 or so. That means it is actually 12.88%. So that is how you calculate internal rate of return by equating the net cash present value to zero. Okay. Now, what is the advantage? If your IRR is 12.88%, you are very sure that even after taking value of money, that means your value of money is going to reduce year after year. Even after taking that account, you are going to get a return of 12.88%, which is more than your normal interest rate. Compare 8%, 9%, 10%, which is more than that. So this investment is more than justified. You are going to get more money by investing in this energy centers by return of through saving. So you can invest in this particular. This is the conclusion that one can draw. So of course there are some limitations of of internal rate of return method also, but let us forget about that because it's more financial than the engineering energy management would not need this. So let's just now ignore this. Okay. So you understood this net present value calculation?
Yes, sir.
Very simple. So I think hereafter you don't have to don't find it that is very difficult. It's very simple. Net present value can be calculated. You can do it with your calculator, or on a spreadsheet on computer, and you can work out. Okay. But for IRR, you have to go on, doing this exercise, what they call as the iteration. That means you change the value of K, work out, change the value of, it is not zero, you work out, you take another factor and do it. So through iteration, you can come to this figure. Okay. So these are the financial techniques or financial instruments, what they call it, which are used by financial people. In practice, you will use normally the payback period method with which all of us are familiar. Internal rate of return also tells you very quickly that, okay, this is going to give some 10%, 20% return. So that is also very, that we also like to use. IRR and NPV, you can calculate it, sometimes you can do it, but not very difficult. Okay, now let's come to the cash flow part of it. As cash flow in case of energy saving project. So what is it? As we have mentioned, initial capital cost and initial investment is for the in the equipment and system subsystem, if there is power supply, compressed air, those installations, everything together. And the net operating cash flow, that is, what is the reduction in, let's say, bills or consumption, that becomes your profit. Okay. And you have to also take into account what is the economic life, that how many years it will give that saving. After such period of time, it may not deliver the same saving. Okay. So you calculate 5 years, 7 years, whatever. And there is one more concept of salvage value. Okay. What is the salvage value? Okay. Let me try to explain in very simple term. Okay. Before we go to the salvage value, let us look at it. Capital cost, net investment, we all know there is nothing much to be discussed, more to be discussed on here. Net operating cash flow is through the savings, so that is actually reduction in your consumption, reduction in your expenses, that you can take it as a cash inflow. Okay, and you can work out, the figure. Now let's come to the salvage value. So what is salvage value? You all know, all of us know, that every equipment that we buy, whether it is in our house or whether it is in a factory or in a corporate, everything has a life. Okay. everything lasts for a certain period of time, or over the period of time, they do the value. For example, one very simple example which I will like to give you is that the television that you buy. You have bought a television, let's say 5 years back, it was a small television, 14 inches, and you want to buy a new one now. Okay. Or you want to say that, okay, now this doesn't have the features, I want to have bigger TV, I want to have better features in the television. So you want to sell the old, you want, but you don't want to just quit, because you know that it is still working. So it has got a value. It has got certain value, but you want to have a new device, so you can't use it. If you just keep it idle, there is no money that you receive. So you may try to sell it. In fact, most of the television shop people will say, okay, we will take your old TV back. I will give 1,500 rupees, concession. What is concession? That is the value of that particular TV, which he has paid to you. He doesn't pay, but he reduces from the cost of the new TV. Okay, or he says the inducement he has given that, okay, your existing TV, you don't, you will still get some money back from it. Okay, that is called the salvage value. In Hindi, or you can call it bhangar, raddi, what you call a raddi, bhangar. Now, everything that you want to sell, even the newspaper that you want to sell, after reading, if you want to sell, it has got some value, and you will give the value. Similarly, utensils, everything. Similarly, the energy saving equipment that you install after a certain time. For example, I will give again one example. In the initial stages, the bulbs, JLS lamp, bulbs, they were used. Now, after this saving concept, we know that CFL lamps were compact fluorescent lamps were came into the market, and people started replacing the existing bulbs by compact fluorescent lamp. Okay, so there was some instrument, some investment in it. After 3 or 4 years, we found that the LEDs came into picture in 2007. So in 2007, people now, because of the very large benefits of LEDs, people started switching over to use of LED. Now, what happens to that investment for CFS? Okay, so you can't sell it because no one will buy it. But at the same time, you must realize some money. So the value that still remains, that means the energy saving equipment or device, uh, because its life is not over, is called as a salvage value. I hope you understood, and you can reduce from the investment, you can reduce that amount to justify the investment for the new device. Okay, you may consider it zero, that for purpose of to be safe on the number of years of uh, payback period you want to be safe, you can consider that value as zero, but it has got certain value. You may take that into account or not. There is certain value still attached to that device which has not completed its life. Is that clear to you? Is it clear?
Yes, sir. Yes.
Yeah. So I think very simple. It is like, like our lifetime examples can be given to you. So every energy saving device that you have installed earlier has a value that is called this salvage value. You can take that into consideration while replacing that old energy saving device with a new device or a new system. You can take that into account, or you can consider zero. That is your choice. Okay. So this is one. The second thing is that I mentioned in the beginning that there is a risk involved in any investment, and there are several types of risks involved. So if the project is really very critical, that your profitability is not very obvious, not very clear, or profitability is low, then they do what is called as a sensitivity analysis or the risk analysis. Okay, what is meant by sensitivity analysis? For example, your energy payback period is depend on the annual saving. Now, annual saving, you calculate for the next few years. Annual saving may depends on several factors. One is that it is the rate of energy. the rate of energy may change over a period of time, next 5, 6 years, is the life of the project. Next 5 to 6 years, no one can say energy cost will remain same, charges will remain same. They will change. Okay. Also, that device may not last for that much period, so that is the risk. So similar is going to be there. So what you do is that you change that particular parameter, which you will decide that the cost and find out what will happen, to it. So that analysis is called sensitivity analysis or risk analysis. So it is varying the cost of the parameter which is affecting that parameter, the saving, and work out whether it is still feasible. If you feel that energy cost increased by 10%, what will happen? 20%, what will happen? Okay, your life is reduced by 10%, what will you can calculate and see that if it is an acceptable image, the change, you can accept that. So this is the sensitivity analysis. Now there are many factors which will affect the uh, the saving, which will affect the payback period calculation or other financial parameters. And these parameters we can categorize into two major headings. First heading is micro factors. So these factors, first is the operating expenses, uh, second is the capital structure, third is the cost of equity, that means the interest part of it, then changing forms, that means the finance, type of finance, which we learn little more about that later. So whether it is living or whether they were taking a loan or whether it is through some other source, that is one factor. Then changing the project types that is another factor. So these are all known factors which are in the control of the organization to installing that particular project. But there are many other factors which are not in the control of any organization. For example, change of interest rates of the bank. You are not under your control. That may change when the rates or financial institution may change the rates of for the loan that you have taken. You have to pay. So with the taxes which are applicable, they also government decides and that sometimes they can get changed for a period of life of your equipment. So also method of counting, method of depreciation, then some extension of the government subsidies. You have considered some subsidies, think that subsidy will be available over a period of time, but they change it, either decrease it or increase it, and your then what profitability figures are changing. So also some regulations they change, environmental regulations, they impose some tax, for example, cess, then you have to take into account. Energy price, of course, you have to take into account. That's not in your control. That somebody else, for example, electricity is the regulators, electricity regulation commission will decide, coal, oil, gas, government decide, and so on, so on. Or also technology changes, you can also changing your profitability. So these are the risk analysis. Is that clear? Is it clear to you, Mr. Awade, Manish? Anuja, is it clear?
Yes, sir.
Okay. I don't know
Yes, sir.
whether.
Yes,
Okay.
sir.
Yeah, I wanted to hear other voices as well. Good, I heard. Okay, now let's go to another important part of this particular financial analysis. That is the financing. So now most of this is also another very, very important, that how you finance the energy saving project. Okay, so there are many ways in which the finance can be made available, or finance can be utilized for energy saving projects. Which are these methods for debt financing? Now, the words here used are here, very bombastic, but debt financing is nothing but you take a loan. All right, if you want to buy a car, you take a loan, which is known. Okay, so you take a loan, which is called, or if you want to buy a house, you take a loan. So similarly, in the same product, you take a loan, and what is the amount you have taken as a loan, you have to repay it in certain installments in certain years, and you have to also pay, not repay the entire loan that you have taken, but also you have to go on paying annual interest on that money. Okay. And the payment that you make is a mixture of part of the equity that you are, loan you have taken, that capital, part of that you are paying, and that part is the interest. And then later on, this proportion changes. Initially, it may be 10% of the payment that you make is capital that you are returning, 90% will be interest that you are paying. And in the end, it may be just reverse. Large part of that is the repayment of the money that you have taken, small part is the interest. So it is loan, taking loan. Okay, is a very normal. I think all of us are accustomed to this, so we did not discuss it further. That taking the loan for some, investment is very normal. Similar to also for other savings first. Second is equity financing. Now this is something slightly different. So there are some companies also, when they want to install some very large projects for every saving, they might they might go in for share issue, get some equity. Okay, equity why you get is you don't want to get a loan because you have to repay it. Equity is something which you don't have to repay. You have to only pay a dividend on it. Okay, so as long as you are promising dividend, you can take equity from various shareholders, and there are many people who are doing it. So also for energy saving projects, you can take equity from them. It is called equity financing. The part of the that equipment cost you are financing the money received as a share capital. Okay, you have to pay dividend on that. That is also very clear. Okay. The third option is retained saving. Now, what is retained saving? Retained saving is nothing but the profit that that organization has received by by investing on energy saving projects. Whatever money you have saved, okay, part of that money you can rather not only all the investment, not only energy saving, but part of the investment that you make, you have profit you have generated through these operations. You can part of that you can invest in energy saving project. Okay, so so that you don't have to get money from outside. You don't have to pay interest. Okay, you are only using your own money profit generated. It is called a retained earning. So which is also very simple to understand. Organization, what its profits it get, it pays part of the money to the organization from that money. Okay. Fourth is capital lease. Now, capital lease means that you are going to install some equipment, and the capital cost of the equipment you get through shareholders. Okay, only that money you get to shareholders. Now, that means that the equipment is on lease. You are getting partnership, and you got to again repay. Installment, you have to pay that money back. And there is another term which is called the true lease. And because the true lease are what we are normally accustomed to. The true lease allows you to make use of the equipment. Okay, with the money that you have received, from an institution. It may be bank, financial institution. They give you money to install that particular energy saving project, and that cost of that equipment. Okay, you pay in installments. Okay, so this is normal method that we buy a car. So we pay that back in 10 installments, 20 installments. Okay, you pay it back. But we are all knowing. You buy TV, you buy equipment, you buy a car, you buy a two-wheeler. So this is so-called a hire purchase. We call it. So this is called the true lease. This concept is, I think, all of us know about it. About this. There is only one problem with lease is that depreciation, as I mentioned, that benefit will go to the agency or institutions which give the finance to buy that equipment on lease. Okay. So this is also very well known. Okay, so this all the four. I hope you understood. 405 Financial 5. Have you understood? Okay, now have you understood?
Yes.
Okay, now let us go to the last one, performance contract. And this is really very interesting. Okay, performance contracting is not only interesting, but it is also going to be very, very useful. Government of India is all backing this energy performance contracting because all over the world it is also accepted as a means of financing energy saving projects. Okay. Uh, so there is let us go to that. What is that concept? Concept is energy performance contracting is a method of retaining a contractor or an agency which will give finance for the energy saving project for a industry or for an organization. It gets the money from that agency. Now that agency will be paid back the amount that is given to you in only on the basis of energy performance or energy saving. That means an agency gives money for, let's say, it's an energy saving equipment. Now, if that equipment, once it is installed, is supposed to give a certain amount of saving that you have estimated, and you are supposed to, if you are getting that much of saving, you pay to be saving part of that, not in full amount, so that after over a period of time, 5 years, 3 years, 7 years, you are paying entire money back to those who have financed it. So, but it is based on energy performance. So, if performance is not as per what is projected, you don't have to pay. That means no payment is due if there is no energy saved, no energy performance, or energy saving is due, they will you pay less. This is the concept of energy performance contracting. So two agencies are involved in it. One is the owner or industry, and the second is the contractor, which is called as the energy performance contractor, who pay, who share the profit in some proportion. Okay, but based on the savings achieved. No saving, zero value, no payment to be made. Okay, if you get more savings than what is contracted, you can share more amongst yourselves, so both get benefited. That is the meaning of energy performance contracting. Now, the companies who are involved in this contracting are called energy service companies. So they are the contractors which are specifically meant for financing such energy performance projects through energy performance contract, and they get the paid only on the basis of energy that is saved in the end. Of course, this is calculation done annually. So if you get returns, savings, and that a part of that is paid to uh, saving. Okay. So these are called energy service companies. Now, this concept of energy service companies in the government of India is all in favor of, they are supporting all energy service companies. In fact, energy consultants, which Bureau of Energy Efficiency has initially, later on, they insisted that there must be energy saving companies or scores. So the government of India promotes this, uh, helps them. So also Bureau of Energy Efficiency. Now, this concept of energy service companies is new to India, say 1995, 96. We started talking about energy saving companies. I think I was there at Kirloskar Consulting. We could talk about it. And I had an opportunity to visit United States to see the various energy performance contracts and see them in operation. So it was about 2 weeks this study, and we studied all this. We also had interaction with the banks, financial institutions, and we saw also projects where the contracts are employed. Now, so this is a very successful, type of method of, financing energy saving projects, and Western countries have accepted it. In India, still it is not still very much accepted because there are some risks involved. People have no trust in these companies and so on and so forth. But government of India wants to support it. So let us try to learn more about energy service company. Okay. So let's define energy service companies are usually the companies that provide a complete energy project services from assessment to design to construction or installation along with engineering and project management services and financing. Now, this energy serving company is not just a contractor, but it can undertake, first, it can undertake energy audit. It can identify the measures for energy saving. It will work out the technical feasibility. It can work out the financial feasibility. The financially feasible solutions can be also financed by them. They can invest in the equipment, involved in it, and they can also maintain that they can operate those equipment, achieve the savings over a period of time, 3 years, 5 years, 7 years, achieve the savings, to the extent of what is estimated in the beginning, and once the results are achieved as per what are decided, and enter into contract between the owner and the energy service company, then he quits. The equipment that was installed as a part of the by the energy service company remains with the industry or the owner. So he get the benefit of that particular thing. This is the role of energy saving companies. I think it will be made, which will be more clear, to this particular diagram. You can see an energy service company at the center over here. Then it takes up energy saving project. It finances energy project. For a company, it installs the equipment, guarantees the saving. Okay. The company in turn pays to energy service company periodically through the saving. Now, energy service company in turn has got procured the equipment for the supplier, and it pays for that equipment. And if required, it may go to the bank's financial institution and get a loan from that. So this role is very well explained in this particular diagram of what is the role of energy saving company. Okay, now let's try to go back. Okay, to this. So I think I hope you have understood the meaning of energy saving contract and energy service company. Have you understood this concept of energy saving? I have understood. Energy saving company, energy saving performance contract. Have you understood? Please answer quickly. Yes or no? If no, I'll repeat. If yes, I'll proceed further.
Yes, sir.
Okay. So types of contract, there are three types of contracts in practice, which are enforced. First is the fixed fee contract. It is called as the fixed fee contract. Second is called the shared saving contract. And third is the guaranteed saving contract. Okay. By what do we mean by fixed fee contract? The energy service company installs the energy saving project for a certain amount of fee, and it gets paid over a period of time. Okay, with the life of the or contract period or life of the equipment in certain installment, and this payment is not dependent on the savings. So whether you get the savings or not, if energy service company has to be paid. Which means that energy service company doesn't take much responsibility for the saving. All the responsibilities, investments to be made, installation of the equipment is to be done by the owner. And so this is just like a consultancy contract, so this is just called as a fixed fee contract. Now some people find it, they say that why should I pay more money? Because fixed fee means that you have to, maybe a small amount of money you have to pay, maybe 1%, 2%, 3%, and not more than that. But the money, everything is retained by the original company. They provide the manpower, they buy the equipment, they install it, they operate it. Actually saying that, and the saving remains with them. Only small fees are paid to the energy service company. This is the first type of contract. Second type of contract, and which is the normal understanding of the energy saving project, is the shared saving contract. What do you mean by shared saving? Whatever the saving achieved, so let's say we achieve some saving in the first year, you share in some proportion, 10, 40, 50, 50, 40, 60, 60, 40, 70, 30, etc. That depends on what is the contract initially entered into. So the energy service company gets a share of the saving on an annual basis. That's called the shared saving. This is a normal task. What we understood energy saving company's role is normally based on this particular concept. That owner will share some savings with the contractor. Now the period of how much will be the percentage of saving, that is to be decided because depending on the type of contract, amount of investment involved, technical capital involved, etc., etc. And third type of contract is the guaranteed saving. That means energy service company will come up with a proposal for, now, sorry, let me explain. In shared saving, right from the energy audit to energy saving, working on energy saving proposal, investment to be worked out, investment will be made by the ESCO. It will be operated, equipment will be operated by ESCO, and also maintained if required. If there is a problem, it will be replaced also for a period of 3, 5, 7 years as decided. Okay. Third contract is guaranteed savings contract where the ESCO carried out the energy audit, it calculates the energy saving project, formulates it, calculates what is the investment required. It says that, okay, owner should buy these equipment, owner should install this equipment, pay to these are the estimated cost. The owner pays for it, owner operates it, and gets the saving. So the part of the savings is, guaranteed savings is given to the ESCO as fees. If you are not, if they don't get the guaranteed savings, ESCO is not paid. Okay. So the risk of savings goes is on the head of energy service company. They will get paid only when energy savings are achieved, and to the extent if the energy saving is reduced, they will get less payment. So it is similar to the shared saving, but this here ESCO does not invest into equipment, nor does it operate, nor does it maintain. Okay, so this is the guaranteed saving, contract. Now, so all these three types of contracts are are being utilized. Now, there are some advantages and there are some disadvantages of energy saving project. First, let me talk about the drawbacks. Okay, so the drawback is that once an owner or company enters into energy saving with contract with a company, he has to abide by that for a number of years. That is mentioned in the contract. They can't come out. If they want to implement some new ideas, also they can't do it because once that project has to be completed. So the owner is not doesn't get the liberty of exploring new areas of what is only explored earlier part of the contract, only those to be implemented. Okay. So there are some drawbacks of this. There are several benefits of design contracts, which we will discuss, later. Okay. So let's go to the benefits. For an industry, when it enters into energy design contract, the first immediate benefit is that it is getting savings, guaranteed saving, agreed saving, projected saving at the expense of all expenditure investment done by the energy service company. A owner or industry does not have to invest any of his money. Does not have to, does not get involved into operation. So the manpower is given by the energy service company. So manpower of energy owners is need to do whatever their operations are there. Third, expertise that is required, because owner may not have to, ask for energy saving product, the equipment available, etc. How much energy can be saved here. That expertise they get from the scope. That technical expertise is available to them. For this, they anyway, since they are not investing anything, they are getting some money without any investment. So any saving that they accrue, they are getting positive accrue. Equipment depreciation, equipment life, this is equipment maintenance is with the ESCO, so they don't have to save any money for that. Okay, so they get without spending any money, they are getting the return. So this is the biggest benefit, and it also is available. Knowledge of new devices, energy service companies will have to have that, which is not available to the owner. That also they will get it. So there are many benefits of that. Okay, and since they are not involved in this, they can use the money that again. They can use it for improve productivity. They can use it for the assets they create, the buildings they can create. So that money they can use it, which they have received without any uh, investment. Okay, so all the benefits that they have, they will be getting it. So theoretically, energy service company concept is really good, and it is to the benefit of the industry, or maybe also corporate also can get it for their building project also, improve the energy efficiency in buildings also. So that can be used anywhere. It's a really good concept. Unfortunately, some problems do arise because they don't trust each other. I mean, owner doesn't say really how what is the saving and actually achieved. He hides it when or because he does not want to pay more to the echo. That can there can be mistrust. Second mistrust can be that energy service company will only tell educate the owner only to the extent required. They will not divulge any other thing. So the knowledge of that project or equipment only remains with the owner. Okay. So there are some problems like this, but more because of mistrust than the real problem per se. Okay. So have you understood this concept of energy saving contract?
Yes, sir.
Okay. So very simple, this it's a common sense. Okay. Now how to develop a SCO contract? Very simple. I will just list down the steps and you will understand. So any organization or a factory industry or corporate house wants to give a contract, contract to some energy company. What it will do, it will first assess whether they have got any projects or they have some ideas where energy service company can help. Okay, they will try to identify energy saving projects and say that okay, this is the energy saving project, this is the cost. You want energy service company to take up the project and conduct a feasibility study. So and this energy service company comes in, does its own audit and try to establish energy saving project with many ideas of energy saving, comes up with the financial and technical analysis and for the technically feasible and financially viable and measures, they will submit a proposal for energy service energy efficiency project with an investment of so much. They will also say that now this investment will be done by us for a period of 5 years or 7 years or 3 years, and you have to pay me some amount of money, 30%, 40%, 50%, you have to pay to us. Now, company will assess whether all calculations are correct, whether the savings estimated are correct, whether they are going to really get that much of saving, whether they are really going to, it is profitable for them to share the percentages and gives a contract to them. So this is the normal method of terminating contract. Once they enter into contract, the contract period may be 3, 5, 7 years. They will implement the project. Then comes with a certain number of saving. But one thing which they need to do is that they have to establish the savings every year. Now this exercise is done normally jointly that end of the first year, second year, third year. they will measure the saving achieved. Okay, so measurements will be not, if some measurements are not possible, they will calculate the saving and say, okay, they will agree, so much saving has taken place, and then they will be sharing it. So measurement is a part of that. And so in fact, there are some measurement protocols, measurement and verification protocols. That means to measure and find out whether your savings are as per what your were estimated or projected. So that's the verification part of it. So there are many methods of monitoring and verification. Measurement, monitoring, measurement, and verification, and they are part of the energy personal contract itself most of the time. So operation then can become very smooth. Okay. Uh, as I mentioned, really smooth with the energy saving company owner does not have any risk to get the money, to that contract. Now I want to ask you, of course, when you are doing energy saving calculation, initially at when your contract starts, you will have some fix some benchmarks, for evaluating what is the money, what is the energy saving, and then measure it every year and calculate the actual saving energy that is saved. Okay. Now I want to ask you one question. If you understood, shall I ask you a question?
Yes, sir.
See, what is the normal energy saving contract period? What should be, what will be? 1 year, 2 years, 3 years, 5 years, 10 years. What is your guess? It is a guess because you may not know.
Normal energy saving contract period means you mean to ask her about the short term and mid term goal we plan or how it is?
No, it is in 40 years. That means in how many years you feel that this contract will be there so that both are benefited. Energy and ESCO must get its money back. Okay. So they are going to insist more number of years. But more number of years may be problematic for owner because he cannot do anything else. So how many years?
हो
मनीष सर बॅग तुम्ही तुमची घेतली का
हो
मनीष सर तुम्ही पाळी बाटली घेतली का
हो
मनीष सर तुम्ही डबा घेतला का
मी स्वतःला घेतलं का
So answer me. How many years? Very quick. 3, 5, 7, 4, or 10, or 1. Guess. Okay.
The minimum one needs to be considered. Means it's we have to be considered for the saving.
For the payment. Yeah, owner has to consider for the payment. So many years. How many years? Okay, let me answer. Normally 3 years, 5 years, 7 years, these are the periods. Okay. Not more than 7 years, not less than 3 years, most of the time. But second most important question that you must answer is, what is the share of owner and what is the share of ESCO, normal? Or what is the range of share? You guess it. Manish. You tell me percentage. 10, 10, 90, 20, 80, 50, 50, whatever. What do you think? It's Akshay.
It can be 10%, sir.
Huh? 10.
10,
10% to whom? Owner or
10% to
ESCO?
the owner.
10% to owners.
Yeah.
Okay. Akshay.
Sir, I think 10% to the ESCO.
Okay. Good. So you are just opposite of what Manish said. Am I right? Okay. Now,
Yes,
okay.
sir.
But you see, normally the share of ESCO will be more because he has put money, he shares all the risk. So he must take money back. So share of ESCO is going to be more. So it can, if it is 60-40, so 60 for to the ESCO, 40 to the owner. That of the case. Normally, it is 30-70, that means 30 to the owner and 70% to the ESCO, or 20-80, 20 to the owner and 80% to the ESCO. And that is the time required for ESCO to get its money back, right? So let's proceed further. Now, here it is considered a case studies for the energy saving project for a building. So quickly we'll go through that. Energy saving in a building can take place in lighting, air conditioning system, or if it is winter heating, if it's a cold area, foreign area, pumping system savings can be there. Canteen can saving, heating use, gas use, etc. So energy service company will do an energy audit study in these areas and work out what are the measures to be taken, what is the investment required, and prepare what is the savings that can be achieved. Okay. So in this particular case, you know, uh, the example is given over here is that there is a company which basic power consumption, that means the energy consumption figures are maintained here, so many kilowatt hour, and it has given a proposal, the total value of savings which sorry, this is not a saving, this is the consumption in 1 year is, when the contract is entered, is 21,28,541. This is energy consumption in the time period is equal to zero when the implementation will begin. Now, owner has, ESCO has guaranteed that out of this, we will save, something like 30%, that's 35%. Suppose it is 39% savings can be achieved. Okay, terms of contract are 5 years, which is a normal period, and then they work out, and measure how much is the actual savings have taken place, and the money can be shared on that particular basis. Okay, so this is typically for any building contract, this type of contract is entered into. Okay, second case which is explained here is, I'll explain very briefly, is that energy saving contract can be entered into by municipal corporations. Municipal corporation, as you know, or municipal committees, they have to look after the lighting in that particular city, or they have to also do the water pumping for the water supply system, sewage supply, some system for that treatment or also they have to, and some corporation may have hospital, schools, etc. So they may run it. Okay, so they normally all these municipal corporations or committees won't have money, and will not have knowledge how to save, energy in their systems. They can buy the service company and say in particular area, they have to, they can engage a service company for that and share savings like what we have mentioned earlier. Now, only thing that things are little complicated because they have to, they can't say to appoint a energy service company. They have to, first identify how much savings are going to be there, estimate how much savings will be there, they prepare their own budget. So for comparing the tenders, now they have to also issue a tender notice. They have to receive tenders from various energy service companies, select one, and which satisfies their requirement, their expectation, and they enter into energy service contract. So this exercise can be done for them also. And of course, industry can have their own energy service contract. Okay. Now let us start. So this is all we wanted to discuss about energy saving companies, energy performance contract, financing of energy saving projects, and before that we studied what are the energy saving performance qualification tools. Okay, so energy criteria for energy saving, better we try to find out. Okay. Now let's try to sell one example which will make few things clear to us. So the example is one oil-fired reheating furnace installed in a factory for heating steel billets, no, from 40 degrees to 20 degrees, in a furnace. This furnace operates for 4,700 hours per annum. The gross calorific value of oil is 4,000, kilocalorie per kg. The specific gravity is 0.94 kg per liter. The furnace oil is 45 rupees per liter, and specific heat of billet is 0.12. Now this is the data given for furnace operated in a factory for heating billet. Now there are some calculations are required to be done. That's example. Now calculate the amount of energy necessary to heat 12 tons of billet. Second, calculate liters of furnace oil fired per ton of billet. Third is if the efficiency of the furnace is improved by say an ESCO from 28% to 30%, so calculate what is the total cost saving. Fourth is that what is the simple payback period, calculation. Fifth is how much investment is required to improve the furnace efficiency. You know, what the internal rate of it over 6 year period. So these are the questions asked. Now let us quickly go through the calculation. The average, the amount of energy required to heat 12 tons of steel billet is equal to, the expression is M into Cp into T. I think we all know about it. We had in the units also, we had it the other day. So 12,000 tons of billet, 12,000 kg, specific, heat is 0.12. That means this is the heat required to increase the temperature by 1 degree. But whereas we have to increase the temperature from 40 to 12, 20 degrees. So you multiply by 12, 20, and 40. Now this works out to the energy required is 16,099, sorry, 60,99,200 kilocalories per hour. This is per hour. So liters of furnace oil per ton, what is required is this is the amount of heat required per hour, and in 12 tons. So per ton means this is to be divided by 12. So you require this by 12 equal to 1,41,600 kilocalories per ton of billet. Okay. And so how much is the energy per ton of billet? Now this because this is per liter, we have calculated per kilocalorie per liter. So per ton of oil, that means how much oil required. You have to divide by the value of the fuel. And so furnace oil required is this value 0.28 is the you have seen that the 0.28 is the is the figure that is the furnace efficiency. So this input required is, this is the actual amount of heat required for heating the billet, whereas the furnace has the efficiency of 0.28. So heat required to actually heat the bullet by efficiency. So much of actually oil will be used. The input energy required per ton of bullet, input energy is so much. Now this is the kilocalorie. So kilocalorie divided by the kilocalorie, specific kilocalorie, kilocalorie of the fuel. So it works out to 50.57 tons of billet is the furnace oil required. Now, what furnace oil required in this is in kg, in liters, it will be, you have to divide by the gravity. So it is 53 liters per ton of oil is required. Okay. How much the furnace oil cost? So furnace oil cost is 53.79 into the rate of it. So you calculate that value can be calculated. So our energy saved it is, for the soil saving is so much of rupees per ton, for 12 tons, so much of energy is saved. Okay. And therefore, the simple payback period is that, it was mentioned here is that you have, uh, you know, it is mentioned in the example that how, what is the simple payback period if the investment is 20 lakhs of rupees. So here we mentioned payback period 20 lakhs of rupees, the investment. This is the amount of saving per year, 4,700 is the number of hours of operation. So it works out that 20 lakh by this figure per kilocalorie, sorry, cost per hour into 4,700. This is the simple payback period. You can go through that calculation at your home. Similarly, for the 6 years, you can also calculate the, that IRR can be calculated by first calculating the NPV. So NPV you can equate to 0, and you can get the, uh, the answer. You can get it. Okay. So I think we will not go deeper into the example, but let's go to the question. Okay, question and answer, because this is very important. Now you will have to answer this question. I will read the question. What does the concept of time value of money imply? Answer A is present value of money, future value of money, discounting of cash flow, and all the whole. What is the answer?
All of the above?
Correct, all the above, because all of them are related to time value of money. Correct. Second question. Return of investment, ROI, is a fraction of. Now this is a formula which we have read earlier. So it is A, B, C, or D. You read this expression, I may say, not formula, but expression. So what we discussed?
Annual net cash flow upon capital cost.
Yeah, this
So
one,
is
B.
it
Which one you are saying? B or C?
C.
Right, C. The annual cash flow, that means return by capital cost, ROI. What is the return you are getting on the investment? So investment has to be at the denominator, cash flow has to be at the in the numerator. Okay, good. Next one. The net present value is equal to A, B, C, D, equal to sum of present values of one cash flows, sum of return, sum of add cost flows, or none of the above.
so D? Because it will be 0.
Not D.
A.
A. NPV is defined as equal to sum of all present value of all cash flows for all the years. That is what we mentioned in the definition. So A is the correct answer, not B. Let's go to the next one. Internal rate of return is calculated by selecting the discount rate so that NPV is 0, equating total discount cost with the total discounted benefit, making sure benefit to cost ratio equals unity, or all of the above. I think we repeated this 4 or 5 times when we were explaining the IRR. So you should be able to answer it. Yes,
A.
correct. A. Discounted NPV is equal to 0. Whatever the discount rate to calculate by using the values, it is the IRR. That discount factor is called the IRR. Okay, go to the next one. Assume project A has IRR of 85%. and NPV of 15,000 rupees. Where project B has got IRR 25% and NPV of 2 lakh rupees. Which one will you implement first? Or which one will you select first? B, A cannot be decided or question doesn't arise. That makes sense. What is important to you? IRR or NPV? That is the real question. Or you are interested in percentage or you are interested in some particular value. Give me an answer. Yes, Akshay, Manish, Anuja, can you answer? I'm waiting for answer.